related to lesson 2. And I thought of finding out how many of you have done before we start with the today's session.
I have started it, but not completed any.
Okay, Murli garu.
I finished the code and coding testing.
That's really great.
I
Did
finished
you get the result?
I think I got the result, and
Oh, great, Krishna. Srini, okay, Mamta garu, good. And how about Srini? You got the output? You can
Me?
compare it to Pradeep, good. Yes, Sumant garu, good. Okay. In today's session, we shall discuss the orchestration and optimization, orchestrator workflow, worker model, and evaluator optimizer. An example related to the AI customer support automation and patterns in LangGraph, augmented LLMs, end-to-end automated client inquiry workflow demo. That's what I have given you. In addition to that, we'll end with lesson 2 with the demo and start with the AutoGen framework, multi-agent systems with AutoGen. Let's see how it works. Meanwhile, what is orchestration? Orchestration in LangGraph ensures that AI agents collaborate efficiently, optimizing the execution order, workflow dependencies, and task balancing. It is like coordinating multiple agents and tasks in a correct order so the final output is accurate and efficient. If you think of a music orchestra, violin, piano, drums, flute, all instruments must play at the right time and the right order so that you'll get the good music. And the conductor controls this. LangGraph is a conductor here. LangGraph decides which agent runs first, which task depends on another, how results flow between the agents. There are the 3 key benefits of orchestration. Number 1, it manages task dependencies in the workflow. The task dependency is all about one task must finish before another task starts. Like, for example, if you take extract order, later extract order ID, fetch order details, check delivery status. Recording is started, Pradeep. Check delivery status and generate response. If these are the 4 steps, how they has to be orchestrated stepwise so that it manages the dependencies in the complex workflow. Then, second benefit, it improves workflow efficiency by optimizing execution, which means running tasks smarter and faster. Suppose we have 2 dependencies. Let's say we have to check the product availability. We have to check the product availability and then check the delivery time. These do not depend on each other. In traditional workflow, A performs first, then B performs. whereas Landgraf orchestration, A and B run in parallel and results in faster response, better resource usage, lower computation cost. This is what workflow optimization. And coming to the third point, it reduces errors by introducing intelligent execution monitoring. In large AI workflows, things can fail, like there may be API failure, missing data, hallucination, might be there is a timeout. So LangGraph can monitor the execution. If you relate it to the 3 steps, step 1 to be the extracting the order ID, step 2 is checking the database, and step 3 generating the response. If the step 2 fails, retry the task, route to another agent, and ask user for clarification. So workflow becomes self-correcting. Workflow becomes self-correcting. And when it comes to the orchestrator workflow model is a system architecture where an orchestrator manages execution flow, decision making, and task delegation, while worker executes specific tasks assigned by the orchestrator. You can consider in simple terms, orchestrator controls the workflow, manage decisions, and assign tasks. And workers perform specific tasks assigned by the orchestrator. You can think of it like a company, manager, and employees. Manager is an orchestrator. Manager assigns the task. Employees perform the work. Later again, manager will collect the results. That's how the orchestrator worker model will work. The orchestrator analyzes the task. It decides how many workers are needed, what each worker should do, in what order tasks should be executed. For example, you have 3 workers in this context. In the diagram, you can see. Let's say worker 1 is all about searching the research papers. Worker 2 extract key insights, and worker 3 will compare the different frameworks. Worker agents or the LLM calls. The worker 1 related to the searching the latest AI agent frameworks, and it will list you all the frameworks. And worker 2 summarizes each framework, and it returns you the output of short summaries. Worker 3 identify the advantages and use cases and gives you the output as an insight. Then synthesizer comes into picture. Once worker finishes their task, the results are sent to the synthesizer, and the synthesizer combines all the outputs into a final answer. Worker outputs are merged by the synthesizer and creates the synthesized report. So that's how orchestrator worker model will work.
Sir Muthinjay
Then,
sir, so I just have
yes.
one doubt here. So what is the difference between the previous example like parallel execution and orchestrator? Because we use the same thing like parallel processing here also, right?
Okay.
So even
No, here,
orchestrator will do the same thing here, right?
no,
It will do the
here you
parallel.
have different levels. That's yesterday I have shared you a document. Have you gone through it, Divya Garu?
No, I didn't go through it. So it
Excuse
was
me?
shared in the group?
Yes, it was shared in the group.
Okay.
So to make today's session more simpler, I have shared a document where you can go through it and understand what's happening. Earlier, we were having entire thing in one single file, and we have separated agent and other things, the main code, workflow, everything we have separated, so that we can develop a end-to-end customer support. You'll get to know more clarity after demonstrating today's demo.
Thank you, sir.
Are we good to continue? Okay. So the orchestrator worker model enhances maintainability, scalability, and performance through decoupling, modularity, and efficient load distribution. Here, evaluator, optimizer model we have. We have two roles here. You can see evaluator and optimizer. Evaluator assess LLM performance using predefined metrics such as accuracy, relevance, and coherence, while the optimizer refines model prompts, worker flows, or configurations to enhance efficiency and effectiveness. It is taking the input. The evaluator checks the AI output using the predefined rules. It checks for accuracy, relevance, completeness, and clarity. Whereas optimizer improves the solution of the evaluator if the evaluator finds the problems. It may modify the prompt, it may adjust the workflow, and regenerate the output. So based on the evaluator feedback, whether it is rejected or approved, if it is accepted, you'll get the output. If it is rejected, it gives the feedback to the optimizer, and optimize will modify the prompt or do the necessary things and improve the. It is all about self-improving loop. You can see an example here. If a summary generated by AI is too vague, the evaluator flags it and the optimizer adjusts the prompt. Over time, this loop improves the summarization quality and relevance. Fine. Next, you can see a very good example, AI-powered customer support automation. A customer service AI needs to first categorize the user query, whether it is a technical or general. If technical, forward to human agent. If general, send an automated AI response. And if it is urgent, escalate it immediately, either by arranging a automated call or something else. That way, the AI-powered customer support system will work. Fine. Right. Like a company might be receiving thousands or millions of customer queries every day. Customer questions might be, where is my order? Or my payment failed. What should I do? The website is not responding, or I need urgent help with my bank account. Might be a number of different queries coming in. And if every query goes to human support agent, companies face big problems. Like there would be some huge operational cost, long waiting times, slow customer response, and support teams may become overloaded. So companies has introduced AI-powered customer support systems, and but AI cannot treat every query the same way. Some questions are simple, few are technical, and few might be urgent. So the system must analyze the query and decide the correct action for that. And the service AI at a center, we see, think of an AI system managing customer queries, and it will route it to the required agent with the help of the orchestration. Next, patterns in LangGraph. Coming to the patterns in LangGraph, we have augmented LLMs. Augmented LLMs, they are designed to go beyond traditional language generation and by enabling the creation of complex workflows and intelligent agents. It takes the input. Let's say, when you consider a real world business problem, an employee asks, what is our company's leave policy for remote employees? If you give the same query for a basic LLM, it will generate the answer, but it may have few issues. Like the model may not know company policies, or it may hallucinate an answer. It cannot access the real company data, and it cannot perform actions like checking the database. So the AI becomes limited and unreliable in this context. Then, to solve such problems, modern systems use augmented LLMs. Augmented LLMs is a language model that enhance with additional components like retrieval system, memory, and tools. Let's say LLM interacts with these three major components: retrieval, memory, and tools to process any query. If you're asking a query like find the latest sales report and summarize it, the LLM issues the query to the retrieval and takes the results. The retrieval system will search the company database, document the storage, and also knowledge base it will access, and it returns the relevant document. Now, LLM has a fresh external information on which it can also access the previous conversation and user preferences, historical context, like suppose the system remembers user is a finance manager, prefers monthly summaries. The response can be now personalized. Later, tools come into picture. It will communicate to the tools for calculating numbers, calling APIs, querying the database, and generating the charts. As a response, you'll be getting a chart saying the Q3 sales report shows a 12% increase compared to Q2. So this would be augmented LLMs contains structured output and tool calling. You can see augmented LLMs generate responses in set formats, ensuring consistency, organization, and data extraction. Like it will give you a structured outputs in the form of a tables or a JSON or a detailed report. Generating a sales report in the table, written JSON for a chart, or creating a formatted summary. When it comes to tool calling, these models interact with the tools, APIs, and databases to perform actions beyond text generation, such as calling services, running queries, and accessing real-time data. If you consider an example, calling a weather API to get live forecasts, querying a flight status service, or fetching current stock prices. Here we have a LangGraph, augmented LLM search engine optimization. We have seen this one at the beginning of the LangGraph, right? To showcase how to use LangGraph and LLM to enhance web search optimization. The traditional web search queries often lack optimization, leading to irrelevant or inefficient search results. Users may struggle to formulate precise queries that capture their intent, requiring multiple refinements. So augmented search queries with a LLM can improve search accuracy and efficiency by generating optimized queries and providing contextual reasoning. Here you can see agent. Landgraph agents are AI agents that operate within a structured graph-based workflow, enabling control and modular execution of the tasks. It takes the input, LLM call, goes and action is performed if any tool is required, and it gives the feedback. Accordingly, the LLM will improve the query and again the action is performed. These agents use a graph-based execution model, allowing for better control over decision-making and state transitions. You can see it helps us, an agent helps us making the flexible decision and ideal for complex workflows. State management, they are beneficial for applications where tracking progress is essential and structured and adaptable. They are designed for automation scenarios that need both control and flexibility. Here comes the demo, which I have given you in the earlier section. So I recommend all the participants to open the document shared you in the earlier session. It will be available on WhatsApp. So I'm sharing you now. And let's open the Visual Studio Code. Sir, please share the yesterday's document again in the WhatsApp group.
Yeah, I just shared before this meeting, so you'll have access to it.
Oh. Right. So whoever has performed the demo, have you taken a separate folder or you started taking all the files in the same folder?
On the same.
Same folder.
Same folder. I thought the same. Of course, for better organization, I would recommend you to take in a separate folder. Here, I would like to create. Hope you can see the Visual Studio code.
Yes,
I'm
we
creating
can.
a folder. Yeah, I'm creating a folder, demo file, in which I would like to copy this. Excuse me. Yeah, demo file is a folder in which I would like to copy the Streamlit folder so that I'll get secrets.toml. Secrets.toml we have got. Now, what is the first file? Your interaction is important. What was the first file you need to create?
State object. State.
Agents.py, right? Agents.py. Agents.py. I'm instead of typing each and every line of code, which is time consuming, and we may not be able to complete the today's session if we do so. So I'm taking the code right away. Agents.py. That's the code. And I shall explain you everything. This agents.py is responsible for, it contains altogether 4 agents, right? What are they? We have intake agent, right? I'm giving you the code. Put it into agents.py inside the demo file folder. It contains 4 agents: intake agent, evaluation agent, scheduling agent, right? And also CRM update agent. These are the 4 agents we have. Intake agent will log the incoming request. Evaluation agent uses the ChatGPT to approve or deny. Scheduling agent will schedule the meeting if approved by evaluation agent. And CRM update agent will give the final system update. When it comes to the importing, we have imported datetime, which is used for generating timestamps and meeting schedulings. And from langgraph.graph, I imported end. It is responsible for marking the termination point of the langgraph workflow. And I am importing asDict from data classes. asDict converts a data class object into the dictionary, which is required by langgraph. And inquiry state, a custom data class from state.py that holds the shared workflow data. So inquiry state is responsible for holding the shared workflow data. You know, OpenAI used for OpenAI client to communicate with ChatGPT, and Streamlit is for web user interface. And also secretly loading the key will be using Streamlit. Fine. We created a client where we can use the client object wherever it is required. And it is responsible for initializing the ChatGPT client, and with the help of API key, which is shared across all the agents. We have 4 agents, right? Across 4 agents being shared. Agent, intake agent, I would like to explain you. Intake agent is capturing the current date and time. Intake agent is capturing the current date and time with the help of datetime dot now dot string formatting of time. We format the time in this file. Year, capital Y indicates 4-digit year, and month, day, hour, minute, and second. So this way we are formatting the date and time. And we are storing the current date and time into the timestamp variable. Later, I am using state.activity.log.append. State contains an activity log, which will help us to append the log entry saying that request received from so-and-so client and at so-and-so time. Fine. And finally, it returns the response in the form of a dictionary, key value pair. It converts the data classes into a dictionary and returns you. Let us discuss the evaluation agent. Evaluation agent now is also making it is using the ChatGPT to determine if the inquiry is approved or not. I am taking a try block. It is used for exception handling. If there is an exception, it will handle it. It will throw the exception, and where except block is responsible for handling the exception. Fine. What we have written in the try block we have given a prompt saying that analyze the following request for approval and respond with only one word, whether approved or denied. I am giving state.request details. Whatever the request user has given, those request details I am sending. Then I'm creating a response client.chat.completions create. This is not new for you. Role as a system and content, you are an AI that strictly decides approval or denial. And later I'm sending the prompt. Whatever the prompt I have defined here, I'm sending that prompt to the content as a user. I set the temperature as 0.3 and the tokens as 10. So I'm setting the system role strictly for acting as a approval or a denial decision maker.
But
And
in
what are
this
the
case,
responses
other
given?
than the prompt, you're not really sending any other context, right? Like how does it decide whether it is approval or denial? Just based on the user query.
Based on the user query. Yeah, see, we will capture the, actually, I'm trying to explain you the agent.py. We have some other files coming in. The entire flow we'll discuss at the end.
Oh, okay. Thank you.
And where you can relate everything. Yeah, thank you, Murli garu. So, whatever the response is given by the model is stored here into the decision. And I'm checking state is approved is equal to decision is equal to approved. State.evaluation nodes request meets approval criteria. And if state is approved, else request does not meet approval criteria. So based on this value associated with the is approved, I'm making a decision here. Next, state.activity.log.append. To the activity log, I'm appending the evaluation nodes. Whatever the nodes is given here, whether it is meeting the approval criteria or it is not meeting the approval criteria, I'm logging it into the activity log. And if there is any exception, I'm setting the is approved to false and evaluation nodes to error occurred during evaluation, and even the error occurred during evaluation, I'm logging into the activity log. So that's all about the exception block. And finally, it is returning the state as a dictionary by the evaluation agent. Fine. Next, we have a scheduling agent. Scheduling agent is responsible for scheduling the meeting only if it is approved, right? So schedules a meeting if a request is approved. If a state dot is approved, whether if it is approved, I would like to get the meeting time and time delta to 1. 1 day within 24 hours, the issue will be resolved, right? It always schedules the meeting only after 1 day. And meeting time, it is formatting to the year, month, day, hour, minute, and second, and storing into the appointment time. And appointment time is again logged to the activity log. Otherwise, if it is not approved, it says request denied, no meeting scheduled. And what are the state? State is returned again by the scheduling agent. Next, finally, we have a CRM update agent. Updates the CRM and finalizes the workflow. CRM log we have where CRM updated with the request details, and we will log the details like CRM updated successfully. And again, updated information is returned by the CRM update agent. This is how the entire flow is there about the agents.py, which is a key file here in this context. So now let's take, what is the next file? Can you please respond? What is the next file?
States.
Excuse me?
State.py.
Exactly. State.py. So I'm taking state.py. State.py, as I told you, it will take the data classes. So I'm taking the code here. Can you see? State.py. From data classes, import data classes field, and from typing, import list. I'm decorating the inquiry state class with the @data class. So it is indicating clearly that it is a data class, which defines the structure of the inquiry state, tracking client details, process the status, and logs. You can see client name, client email, request details. So it captures while enter accessing the end-to-end customer support system. It captures the client name, it captures the email ID, request details, and later it will decide whether the is approved is evaluation notes. Initially, these all are empty. Okay. Is approved is false and evaluation notes is empty string. Appointment time is also empty string. CRM log also empty. Activity log is also field dot default factory is equal to list. So here it is defining the single source with the client details and a decision, scheduling info, CRM updates, and full activity log. All the details it is having. And you can consider this as a brain memory of your agent, as it is storing all the details. Fine. I would like to give you the code. I recommend all the participants to create state.py in demo 5 folder and put this code there. You done? We are going ahead with the next file. What is the next file? I'm waiting for your response.
Workflow.
Workflow, right? Okay. So workflow is not new for you. We have been discussing the workflow right from the second demo. And I would like to create a full file, new file, workflow.py. And here is the code, workflow. Workflow is all about, I request you to create a file, workflow.py. Yes, RJ, next is the main.py. Workflow.py. Workflow.py contains a function called as construct graph, which is responsible for building the LangGraph state workflow for inquiry processing, and the ChatGPT logic is handled inside the agent functions. As I told you, we have 4 agents. We are creating the 4 nodes: add node, intake agent, add node, evaluation agent, add node, scheduling. The name I'm giving to the node is scheduling, and agent is scheduling agent. What are the functionality I have defined in the agents.py, right? In the agents.py, we have defined the functionality. Agents.py, scheduling agent we have, right? So the same node we are creating here. Node is all about functionality. And one more node we are creating, CRM update agent. Later, add node, we are ending the execution. It is termination point. Lambda state as dictionary of state. Whatever the state is there, with the current state, it's going to end. We are setting the entry point, connecting the nodes now. From intake to the evaluation, to the scheduling, to the CRM update, till end. This is the worker flow we are setting up. Then set finish point. I'm saying end. Later it will compile the entire workflow. And also in this context, I would like to visualize the graph as well. Not only for this, the earlier two demos, demo 3 and demo 4, for those also, I recommend you to work on visualizing the graph. We didn't discuss them, and I thought of giving you as an assignment. So I recommend you to visualize the graph for demo 3 and demo 4. For demo 5, we are discussing the graph. Here, directed graph, it is generating using network X. You can see the imported. We have imported network X, which will help us in creating the directed graph. And the plot will plot a figure. Line graph, state graph, you know. And from agents import, I'm saying, right? From agents import. Here is the agents. So from agents, I'm saying import intake agent, evaluation agent, scheduling agent, and CRM update agent. Every Python file is considered as a module. And here, these are all the modules, right? We were importing. Similarly, agents is a module which we created, and it contains these functionalities. I can import it to the current file workflow.py with the help of from agents import, intake agent, evaluation agent, scheduling agent, and CRM update agent. If you are not importing, you will not be able to use them during the creation of the nodes. That is important. Fine. Yeah. Then visualizing the graph, we are creating the edges and adding the edges to the graph, add edges from edges. So it will take the same order, whatever the order you have mentioned here. From start to the intake, from intake to evaluation, from evaluation to scheduling, from scheduling to CRM update, and from CRM update to end. Then when you call figure, it will create a figure with 8,5 width and height. And when you call draw, it will use graph with the labels as true. What are the labels you have taken? These edges as the labels. And node color as light blue, no edge color as gray, node size as 2000, and font size as 10, font weight as bold. It will create the figure. And if you want, you can call save figure using matplotlib.pyplot, which will save the figure into your folder as workflow.png. And I would like to return workflow.png here with a visualized graph. Hope you understood. If you are comfortable till here, if you say yes, we shall proceed with the main.py. Excuse me. Are you
Yes.
okay? Shall we go to main.py?
Yes, go ahead.
Great. So I'm taking a new file, main.py. Main.py contains the user interface. So let me take the code. This is a code related to the main.py. What it does, it's importing the inquiry state, it is importing the streamlit and workflow related construct graph, visualize graph, data class related as dictionary, matplotlib related ELT. And def main, see this your execution point for this current demo will happen from here. If __ name equal to main. So it will call the main first. When main is called, it creates the Streamlit user interface for inquiry processing system. And it will create a title, automated request handling system. And it will ask you to enter the details below. And as I told you, your end-to-end customer support system asks you for the username, email ID, and what is the request you have, right? And I would be entering the name, email ID, and request details. And you create a submit button. When you create a submit button, when the user is clicking on submit button, this condition will execute. What is that? What are the details entered by the user is captured into the respective variables of inquiry state. Inquiry state is a class we created here, state.py. Can you see? With these variables, right? So into these variables, the user inputted data will be stored, right? Please concentrate. We are getting into the flow. Whatever the details entered by the user is captured into the data classes inquiry state with the variables client name, client email, and request details. And the inquiry state object is converted to the dictionary. Dictionary like client name, the user entered name, comma, client email ID, the user entered email ID, comma, request details with the user inputted request details. And construct graph is a function I'm calling. And invoke a state dictionary. So final state, then it is processing the request. When you call the construct graph, it will go to the workflow.py. Workflow.py has a construct graph, right? It will construct the entire graph with the required nodes and edges given to it. And it returns you the entire workflow. After returning the entire workflow, it is stored into the process graph. And over the process graph, I'm invoking by passing the state dictionary. State dictionary contains all the key value pairs inputted by the user into the inquiry state variable. And it is passed to the process graph dot invoke so that it will take these details and it will invoke and store into the final state. And later I can say request process successfully. Then evaluation outcome, I would like to print the evaluation outcome. If final state dot get, if the meeting is approved, meeting schedule time we will be getting. And CRM update also, CRM log you will be getting onto the user interface. And activity log also will be getting. Right? So these all are by default nothing here. They are nothing, empty values. Later, when it is executed, as per the response, it will capture the required data and display it onto the user interface. Finally, we have visualize graph, where I would like to get the graph by calling the visualize graph function, which is mentioned in the workflow.py. You can see workflow.py, you have visualize graph, right? In the visualize graph, we have the graph creation related code, and it is creating workflow.png. When I call this function, it will return the response, the graph, and I'm showing it onto the graph. Excuse me, I would like to uncomment it so that I can show the workflow. Okay, right? So I would like to give you the main.py code. Any code missing, please let me know so that we shall run the demo. And now you need to tell me which file I need to run to get the output. As we have multiple files here, right? Which file to run?
Main.
Exactly, Murli. Main.py. So I'm running the main.py. So to run the main.py, what we need to do? Streamlit, run, all of you. Sorry, I'm where I am? I'm into the lesson 2 folder, right? So I need to get into the demo 5 folder. So cd space demo 5. I'm into the demo 5 folder. If you want, you can check it out. You have all the files here, right? Workflow, every file is there, folder is there. Fine. Streamlit, run the file name main.py. You're getting the Streamlit output. You can see. Please confirm me whether you have got the output on.
Yeah, received the output.
Yes.
Yeah. So I'm inputting a query. So let's say it is asking for all the details, right? Let me input a email ID, sample@gmail.com. Sorry, name is Mendu and sample or mendu@gmail.com. And I would like to have a request saying that I ordered a product and delivered a different product. So this is the query. Submit the request. What's happening? So this is the worker flow. You can see the image. It's generating the response. Murli garu, Divya, are you comfortable? You were having some doubts, got them clarified?
Yeah, Mrutyunjay garu, it's fine now. So I'm able to understand.
Great, Andy, thank you. So when you submit the query, it is saying request processed and evaluation outcome. You can see error occurred during evaluation. CRM updated with request details and activity log you are getting. Can you see?
We have written the code, but not as far as what you have written.
Okay.
I
You have
think
written
so.
in a different way, right?
Data class we didn't take. I took the type dictionary thing.
Okay.
Yeah, so
No
just
problem. See, to the same problem, you will have different approaches. One
Okay.
problem, multiple solutions always.
Mhm.
And
Yeah,
we
this-
cannot say my
Mhm.
solution is right and your solution is right.
No, yeah, it's,
Two
I don't know.
different perceptions.
Yeah.
yeah,
So,
this one is
Mrutyunjay,
more polished, and it would be helpful for our future files for sure.
Yes.
A very
So
dirty
Murli,
code we wrote.
what is that? What is that? I mean, this. I mean, if you scroll down, what is that? The start and the graph tell
This
us
graph,
about?
right?
Yeah, this one.
This graph is the nodes and edges connecting graph, process workflow. We have nodes, right? Intake, evaluation, scheduling, and CRM update agents. How they are
Mhm.
communicating, the related
Yes.
graph.
And this has been changing as we input the data or process it.
No, what is the way we have created the nodes and edges? It will connect accordingly.
Yeah, that's basically a static one. That's not
Yeah,
nothing to do with what your input.
anyways, only to in order to show you, I am disabling it. And whenever you change your file, it will ask you file change and rerun. Yes, I am rerunning, and the graph will go off. Right? Okay. These are the details I entered, and I am inputting another query. How to reset the password.
So yeah, this is where I was asking a question before, like, we are not providing any other intelligence to the LLM that says that, okay, accept this kind of request or reject this kind of things. It's going by general things. For example, I entered add a music player but received pen, right? And then I got a response that request does not meet approval criteria. So we're not really
Okay.
providing any criteria on what is approved, what is not approved. So that's basically my question. So
Yeah, see,
Yes.
I mentioned as I ordered a product, but the product delivered was different. It came as approved criteria, approval criteria.
Okay. We need to optimize.
yeah. So we need to tell it what kind of things it should automatically approve, what kind of things it should not approve. Right. That is the part that we have not given so far. So.
Okay. I would like to input saying that I need help in automating the invoice generation in my business. Let's see how it responds.
Where does the self-improvement process is going on? Did we do anything for that in the code, or it's not that intelligent?
Nothing has been done.
Okay.
Only we are having a different approach towards this problem. And we created agents where it can schedule based on the approval and denial. If the model can address this query, so you can see all the time you are getting the error, request timed out, no meeting scheduled. So
Try the way I entered. Like I entered
are
just
you getting any different outputs at your end?
no, I entered like
Yeah, I'm getting proper output.
I'm getting
Yeah, what is that you entered? Can you please give me the prompt?
Yeah, for example, I ordered music player but received pen. So
I ordered
here,
a music player, but received
pen.
a different one, right?
Yeah.
received a pen.
Your voice is not clear.
Received a pen. Pen pen.
Received a pen. Okay.
I wish I would have taken the other way around. Ordered pen and take the music player.
I tried in
And
a
you'll never complain about it.
generic way. It worked. I ordered a product, but the product delivered was different. It worked as approved.
Okay, okay.
Maybe you have some connection issue and for your thing, I think.
Might
Oh,
be.
yeah, we are all getting. I think I also got positive and negative both use cases.
The same code I'm using, but
Yeah, that is called AI, right? AI will not give the same result every time.
yes,
AI can change the result like even if you try the same code again multiple times, Krishna, it will give a different code for you.
yeah, you're right.
Yeah, AI is not the unpredictable results always.
No. He's getting requested timeout. Something I think, right? There is an error.
You have put the same code, right? Whatever I have given.
Let's do one thing, Mrityunjay, like copy the
I
code, like in the chart window, they are sending the codes, right? Just copy that code and paste it here.
unfortunately I have little different code and I already working, so
Yeah,
I
little
did
different.
not change that.
Okay. So let me see. Please set my email account password. So your request is being processed. Request processed. Oh, there is a. Okay. I'll fix it in the next session. I'll figure out.
And also, I think we need to enhance the system prompt for the inquiry agent.
Inquiry agent.
Yeah, right now we are simply saying that you're an AI agent that strictly decides approval or denial, but we're not giving any criteria on what is approval. Like for example, if we add that says that okay, if the request comes from related to a product pricing account, then approve, everything else deny.
Okay, I say you are a agent. A that process e-commerce queries, right?
Yeah.
Right. I changed the code, and you can see here. Streamlit rerun.
Same code, it works for me.
Yeah, same code, it
Rerun.
works for me as well.
Yeah, it works for me. Same code.
Is it okay?
Yeah. The code is working. It's about the accuracy of approvals and denials.
Let's see. Yeah, I can see your responses. Good, Krishna and Venugopal. No. Okay, there might be some issue. Yesterday it was working fine. Hope you got the desired output.
Yes, and yeah.
Yeah.
request does not meet approval criteria. Is that a proper outcome?
Yeah, maybe.
But something should be done, right? If you ordered some product and we got a different product, the outcome should be like a new ticket is created or someone will reach out to you. Why it says the request does not meet approval criteria?
Right, Kishore.
Based on its guidelines.
Maybe, yeah, it's not. I think that's where they use RAG for these kind of things, so that exactly based on the prompt, you get the actual message. But yeah, I think this model is giving different output.
Yeah.
No, I think we are asking the model to just give the approval or denial, and based on the approval or denial, we are writing the code. So we have not written such in-depth coding here. All we are saying is if it is approved, in this case, we are asking the model just to evaluate the request and see if you can give us just approve or denial. That's it.
So what
Then
cases generally goes for approval?
that's what we are relying on the LLM. So if you give the order or the proper complete request, sometimes it is giving approval and sometimes it is giving denial. So it depends on how much information you are giving it, so that the LLM model decides, okay, this is a proper request and this is an improper, or this is spam request, something like that.
Oh, okay. So generally a password change request is something that can be approved.
Probably. we need to play around that LLM. Yeah.
Okay, yeah.
So if
Yeah, I
you
changed the prompt a little bit. It seems to be working. I just changed it
yeah,
to
definitely. So if
yeah.
you look at this agents.python file, so we are using the OpenAI chart completion, right? So that's where we are expecting to return Boolean, whether it is approved or denial. So that's all we are expecting to return from LLM agent.
Oh, okay.
Maybe just wording change, and I ordered a laptop, but I received pen, something like that.
Yes, I'm working on it.
How many ordered laptop and how many got pen?
Yeah, some issue. There might be some issue with my API.
Yeah, I see payment failure for all of you guys here in the back end.
Yeah.
Can you give your credit cards?
This is the automated inquiry system.
Do you want try our access key, Andy?
No, I think he was kidding.
Mrityunjay garu. So we can try.
No, I can create an access key, but we are getting
Maybe